How's it going, everyone? And in this video, we are going to be talking about encoding and decoding in Python. And we're going to be looking at how we go from a binary representation of some number into bytes, and from bytes, how do we encode these things into characters that we as humans can understand, and how we actually communicate with computers at the end of the day. So it's some pretty cool stuff, very fundamental stuff, and we'll jump into it. So, as we are hopefully familiar with, computers basically at the super low level talk in ones and zeros. That's all they know, is just one and zero. And so basically the question is, how do you go from ones and zeros into things like letters and phrases and words that we actually can, as humans, understand and use to actually write code and scripts, and read web pages and stuff like that. And so basically at the end of the day, what fundamentally happens at a very low level is that we are taking these collections of ones and zeros, we group them into sets of 8, and we call that set of 8 bits. So a bit is a 1 or a 0. 8 bits makes up a byte. And so when you have 8 bits put together, it's basically corresponding to a summation of a bunch of these placeholders for, or the coefficients in front of 2 to the 0th power, 2 to the 1st power, 2 to the 2nd power, all the way up to 2 to the 7th power. And so basically when you sum all these things together, if every single one of your bits was 1, the biggest value you can make is 255. And if all the coefficients or all these numbers are zeros, then the smallest number we can make is 0. So basically what we have here is a range inside of this little byte, that this byte can take on some value from 0 to 255. And then as humans, we don't really look at numbers all that well because it's hard for us to map these very quickly. So we created these things like ASCII. And so if you go on Google and you look up, the ASCII table, pretty quickly what you'll find here is that, us humans have agreed that we will call the number, let's go with 77, that will refer to the character uppercase M. So if we have a byte that is equivalent to the number, or has the value of 77, when your computer reads this byte, if it is using the ASCII encoding, it will call that the character big M. And so from there, as you get an even larger group of bytes together, like if you had an array of bytes, now you can begin to put characters together, and you make some words like hello or whatever. But that's how this thing's beginning to scale up, kind of from a theoretical perspective here, is that we are using these tables, these ASCII tables, to encode these bytes. These bytes have values from 0 to 255 depending on the value of the bits that make up the byte. So hopefully this is all coming together. And so now, with all this stuff in mind, there's some pretty cool built-in methods in Python that I think we should familiarize ourselves with. So when I'm going to run this little print statement, and I'm going to say print, and if we go to here and we say ord, it's a built-in method. And I'm going to pass it in a character. So I want to know what the character big H corresponds to. And so I'm going to run this in my little PyCharm terminal. And so basically what Python's telling me is that when it sees the character H behind the scenes, this character, this byte, really is the value 72. And if we wanted to get even more fancy in here, we could say, okay, well, what is 72 in this binary language? And so what we can do is we can say bin, so binary. It's another built-in method in Python, and we can pass it just 72. And then when we run this guy, so I'm just going to print this out just so we can still see it on the console. And just run it. So you can see that Python kind of kicks you back with this 0, little b, and then 1 0 0 1 0 0 0. And if you're doing this and you're wondering, or you want to truncate that leading 0b notation, you can just do 2 colon and then leave it like that. Rerun this guy. Now you can see this in your typical binary notation. So basically what this is telling us is that this character H, and what we can even do to be a little bit more fancy is pass this guy in and run it, and you can see we get back the same thing. But what it's telling us is that the character big H corresponds to the byte value of 72. That byte value 72 literally has no is not an object, because that's something that, I think very easily people kind of get wrapped up in Python, myself included, looking at these things saying, it's a character, it's a string, it's some kind of dictionary or whatever. These are dimensionless things. They are just literally the value 72. And when we express the value 72 in binary notation, this is what we get back. And so this is how Python behind the scenes is encoding this binary notation 1001000. So when it sees this value in memory and it encodes it, it is going to present to you, or it's going to think of this as really the character big H. And a little nuance about Python is that it's not using the ASCII table like a lot of other things are. It is instead using UTF-8, and the -8 at the end means that it is a 8-bit basically map. So it's mapping the values from 0 to 255 for all these different numbers. Like, how are we going to map these to characters? And so that is what's going on behind the scenes here. And so, just to kind of hit home, like what's going on here, I like to just kind of bring this together with a little story or example. So if we had the term, and I know everyone loves saying hello world, and let's put a little exclamation point at the end of this guy. So if I pass in this term, hello world, what is it really? So hello world is just a string. A string is a collection of characters. And as we were talking about right now, these characters are really just bytes, and these bytes are really just collections of bits. So how about we go and work all the way backwards from the actual string here into the binary notation that makes up this entire string. So to do that, what we'll do is we're going to start iterating through this guy. And so what I'm going to say is, I will say this. So I'm going to say Unicode values, and that'll correspond to stuff like 72, or whatever thing is in that range from 0 to 255. I'm going to initialize an empty list, and then I'm going to say for, and then I in term. So basically we're going to iterate through every single character inside of this string. What we want to do is we want to basically grab that or look up what is this specific character's value in bytes. So Unicode value will be equivalent to, and then here's where we're going to use the ORD method of Python that's built in. It's telling us this stuff, and we're just going to pass in I, and then I'm going to append this to, sorry, one second. I'm going to append this to the actual Unicode value, and then we will print out that Unicode values list just like that. And what I'm also going to do here is I will comment this guy out. What we can see here is that this, we'll print out this term right there. So hello world, when you break this thing down into its constituent bytes, so this string has characters, and all these characters have these values, and this is what it looks like behind the scenes. So now that we know what all of these Unicode values are, the next thing I'm going to do here is for UV in Unicode values, I'm going to now look up and I'm going to declare a binary notations, and we'll just pass this guy in. And so what we're going to do here is I'll say binary notation gets, and then another built-in function of Python, that bin or binary. And so we're going to basically look up that UV for each one of these guys, and then we will pass in or append this in just like that. And we're going to then print this guy. And again, if you don't like the prepending of that 0b, you just do 2:, just like that. Run it again. So now we can see, as we're decomposing our string at the high level. We've got the byte values. We now have the binary values as well. And then finally, what does this look like to your computer when it's, actually running all this stuff? And so what we have with that, if we wanted to look at this in purely just the before the binary format, not even byte format on your hard drive, you could just do this. So you could say binary raw, why not? And then we will just join basically all of the stuff inside of these binary notations. And I will then print that bad boy out. And so that is how Hello World looks like to your computer. And so this was something that took me a good while to figure out. But I think it is a pretty interesting topic and stuff to understand for, when you're working with computers, what's really going on behind the scenes. So, if we were to save the string hello world onto the hard drive right now, or ask ourselves, how is this string hello world living in our memory right now and in our RAM? It is living in our RAM looking exactly like this. And so we got this by basically decomposing this thing, by decoding the encoded string into its byte, and making that byte array, and then from that byte array getting the binary values or the binary notation for each one of those byte values, and then basically concatenating all those things together. And that is how we end up with this. So I hope that this is interesting and helpful stuff. Very, very fundamental things to computer science, and I wish I knew it sooner, but hopefully it was helpful. So thank you all for watching. Let me know if you have any questions, and be well.